Hey everybody, we're going to be talking about functions today. Chapter 3, lesson 4. All right, so these are your 3 warm-ups for the day. What I want you to do is come up with what 3 terms come next in each of these problems. So what comes next in each of these problems? All right, so pause, get it going, go. All right. So this very first one, we have 9, 12, 15, 18. What is happening to each of those? You are adding 3, add 3, add 3, add 3. If I continue that rule on, I will get 21, 24, 27, 21, 24, 27. Next, negative 8, negative 3, 2, 7. What is happening to each of those? I am adding 5 here. Add 5, add 5, add 5. If I kept going, I get 12, 17, 22, 27 would be the next one, but I only need 3. Oh, man, sometimes you just get a little too excited. Okay? Gotta love math. 12, 17, 22. The last one's a little tricky. How is the last one a little tricky? Well, you add 1 here. Add 2 here, add 3 here, which means I add 4 here. Next one is going to be add 5, so at 24, then add 6, 30, and add 7 to get 37. 24, 30, 37. Okay? So that's what we're going to be talking about with the next 3 terms. We're going to be doing this today, except with functions. Okay, so we're going to be learning to represent functions with tables, graphs, or equations. So all 3 of them are going to be in today. So I hope you're buckled in, ready to go. We got a lot of stuff to cover. A lot of stuff to cover today. So I hope you're ready to go. Excited time. Let's go. Okay, very first thing I want you to write down is function, input, output. Pause, write it. All right. So a function is a relationship that compares 2 quantities. One thing I want you to see, it has exactly 1 output for each input. There's 1 output for each input. I will say that one more time. 1 output for each input. 1 output for each input, yada, yada, yada. Okay? An input, what are we talking about? So functions are dealing with outputs and inputs. But what is an input? What is an output? An output is your x-coordinate, something that you plug into your equation. Your output is your y-coordinate, something that you get out of your equation. X-coordinate goes into an equation. Input the information into it. It goes in to the equation. Output is your y-coordinate. Your y comes out. Y output. Output y. Why is it an output? Because it comes out of the equation. All right? Next to domain and range. Pause right now for your domain and your range. All right, so your domain is the set of all input values. Your domain are your x-coordinates, all of your input values. So if you think about your domain and your input, those are also known as your x-coordinates. It is your x-coordinates, all of them. Your range is the exact opposite, is the output values. I know you probably have talked about range being like mean, median, mode, and range. In range, as far as a graph, that is all of your y-coordinates. It's very important. All of your y-coordinates are your range. Your range is your y-coordinates. Your y-coordinates are your range. Okie dokie, artichoke. Let's get into it, a couple examples here. So here's one that you do not have to write down, but I want to explain. It says, make a table and a graph of y equals 3 minus x to the second. So I'm going to make a table and I'm going to graph it. The very first thing I'm going to do is make my table. All right, so my table will look something like this, where I always want roughly, let's say, 5 points in here. Okay, so I'm going to have my x, I'm going to have my equation of y equals 3 minus x squared. I'm going to have my y, and then I'm going to have my coordinate of x, y. Okay, and what I'm going to do is I'm going to be coming up with coordinates. In my coordinates, I'm going to come up with, let's say 5 of them. I'm going to come up with the 5 quick ones. I'm going to come up with -2, -1, 0, 1, and 2. You may be wondering, how in the world did I come up with these numbers? Well, I came up with these numbers because those are numbers that I can easily put into this equation. Okay, easy numbers that I can work with. When we are plugging things in, when it says make a table and we're going to graph it, okay, we are going to be plugging in points for ourselves. It might not always tell us what our x and our y is. So what I do is I come up with my own values for x, and then I solve for y. Okay, I came up with my own values for x. So x is -2, -1, 0, 1, and 2. So what I do here is I have all of these x's and I plug it into my equation. So I get 3 minus 2 squared. My next one, sorry, -2 squared. My next one would be 3 minus -1 squared. Next one is 3 minus 0 squared. 3 minus 1 squared. Next one is 3 minus 2 squared. And how I'm getting all of these numbers, my 2 was plugged in right there. My 1 is plugged in. My 0, I plug it into the equation. -1, plug it in. So now what I do here is I solve. So I take 3 minus 2 squared. Well, what's 2 squared? -2 times -2 is a +4. 3 minus 4 is a -1. Okay, go to the second one. 3 minus a -1 squared. -1 squared is 1, a +1. 3 minus 1 is 2. All right, 0. 3 minus 0 squared. What is 0 squared? It's still 0. 3 minus 0, 3. 3 minus 1 to the second. What's 1 to the second? +1. 3 minus 1, 2. 3 minus 2 to the second. What is 2 to the second? 4. 3 minus 4, -1 again. Okay, so as I do this, this is very important. Now I need to put this into ordered pairs. Okay, so my ordered pairs are going to be -2, -1. -1, 2. 0, 3. 1, 2. 2, -1. You may be wondering, where am I getting these points? They all come from this column and this column. Where my x is 2, -2, my y was -1, and I take those two numbers and I plug them into these into that coordinate pair. Same thing, next one, my x was -1, my y was 2. I plug it into that ordered pair, and I just keep continuing on until I have 5 points. Now, once I have 5 points, I graph them into a graph. In my graph, after I have this table, okay, I graph it, I get a graph, and it comes out to look something like this. These were my points. My points were 0, 2, -1, 2, 1, 2, and I had -2, -1, and 2, -1. Those were my points, and notice how I connected those points with that curved line. Okay? Now, also notice I went right down the line here, and I didn't start connecting lines like this. Okay, I started from my left side and I connected the dot from the far left. Okay, so I started here with this point and I moved up to this, and I'm moving from left to right. I'm connecting dots from left to right. Okay, so the very first thing I did was I came up with a table. Second thing I did was I put my x's into my equation because I came up with my own values of x's. Third thing I did was come up with the ordered pairs. Fourth thing I did was graph. Okay, so come up with a table, plug in your x's, get your coordinates, and graph. All right, so try that and this next one on your own. To try this, make a table, get your points, plug in your points, graph. So this is what your table should look like. So when you plug in your points, I am going to plug in, and you may come up with 5 different points. That's okay. Come up with points that's easy for you. I'm going to plug in the points of -2, -1, 0, 1, and 2. I came up with 5 points. And when I plug these in, this is what my final table would look like. So I have my points of -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. And it's all because I plugged in my x here into the equation that was given me right here. I plugged it into that equation, gave me it right at the very beginning. I plugged in my x values, I solved for y, and then put my x and my y into my ordered pairs. Now, you may have come up with something a little bit different, but as you do this problem, okay, you're going to be graphing now. As we do this problem, we need to start graphing the points. So my point is -2, -1. So 1, 2, down 1. -1, 0. 0, 1. 1, 2, 2, 3. Notice I have a straight line. I'm going to connect these dots here. Your graph, even if you did not use the same points I did, that's okay. Your graph should be similar to mine. It should be a diagonal line that goes up and to the right. Up and to the right. Okay? Awesome. And on the same, kind of the same line. Fantastic. Next. So we've talked about a function a little bit right at the very beginning. I explained what a function was, but then we kind of got off the idea and started plugging things into equations like we did in chapter 3.2. Now, if you have a relationship that is a function, each input has exactly one output, and one output has exactly an input. So when the relationship is graphed, use the vertical line test. Okay, so if it is graphed, use a vertical line test. Okay, so what that means is if I look at my graph, let's say I have a graphed line, there's my coordinate plane, my blue line is going to be the line that I just graphed. The vertical line test goes like this. I just place an imaginary line down on this graph, an imaginary line, I don't have to draw actual lines, and I make sure that a line, a red line, only intersects that blue line in one spot. Okay, for instance, my graph like this, my blue line is only intersected by a red line, this red line at that point. It's only intersected by this, the second red line, at one point. Next red line at another point. So this is a function. Okay, a not function, an example of a not function when you use the vertical line test is something like this. Notice how if I use my vertical line test, which is my red lines, I put my red line straight down and I hit my graph line, intersect it in 2 spots. Okay? If it hits it in more than one spot, it is not a function. It is not a function if I intersect at more than one spot. All right? Okay. You don't have to write this down. What we're going to be talking about is what happens if it's not graphed. Okay? So I have my points of 2, 3. So this could be, if you look at these could be points. Okay? Now, if I look at these points, we're going to be looking at every input has exactly one output. Every input has exactly one output. So if you look at this, notice what is my input, what is my output? X or Y, which is my input? X. X is my input. What is my output? Y. Y is my output. So if I look at this, if I'm using an equation, it tells me that when my x is 2, y is 3. Okay? I'm fine with that. When my x is 3, my y is 4. Okay? My next one, when x is 3, my y is 5. Notice how my input has 2 outputs. Does everybody see that? My input has 2 outputs. We cannot have that. We cannot have our input have 2 outputs. I will say that again. Our input cannot have 2 outputs. If I plug something in to a function, it will always come out the same number. Okay? The same number. For instance, if our equation, it always deals with an equation. If my equation was y equals x plus 1, if I plug in 3 here and I add 1, my answer is 4, right? Every time I plug in 3, it will always equal 4. Okay, let's try it. Let's plug in 3 again. 3 plus 1, 4. Try it again. 3 plus 1, still 4. Notice how in this equation, or this function, or they say, we're seeing if it's a function, in this table, my 3 goes to 2 different outputs. We cannot have an input go to 2 outputs. So, does this represent a function? No. This is no function, not a function. Okay? This is not a function on this. All right? One input can have an output. Each input has one output. I want you to write this down. Pause now, write this down. Now, using the vertical line test, using that vertical line test, I want you to tell me, is that a function or not? I'll pause. Okay. Is using the vertical line test. Remember we talked about the vertical line test when I gave you this graph and I told you the blue line was a line and I said vertical line test was my red line. Okay? If it hits one spot straight up and down, it is a function. It hits one spot every single time. If it hits more than one time, it is not a function. So I want you to try to see if you can tell me if this is a function or not. The question is it a function? No. This is not a function. So no function, not a function. No function. You can write one of those two things. Okay, because if I used a vertical line test, and I'm going to use a dashed line for my vertical line test. Okay, I use my vertical line test and that hits my graph at that point and that point. It hits more than one spot. If it hits more than one spot, it is not a function. So because my vertical line hit more than one spot, it is not a function. All right? Awesome. This one, you don't need to rewrite the directions, just write the graph and tell me, is that a function? Pause right now, use the vertical line test, tell me, is that a function? Yes, it is a function. Yes, this is a function. So you can just write function if you want, but this is a function. The reason behind it, it does not matter where I put my vertical line. I only will hit this graphed line in one position. Okay, I could put my vertical line here, only hits my function or my graph line there. Could put it here, only hits my graphed line there. Okay, so there's only one spot where it will hit. So is this a function? Absolutely, absolutely. Okay, now this one says determine if the relationship is a function. Okay, and it gives us y equals x to the third. So what we have to do, like the problems before, is I have to come up with a table, like we did on the first two problems. I have to come up with a table, and I'm going to plug in, again, 5 points, and see if you think, and after graphing those 5 points, see if it is a function. Okay, if you think this is a function. So, graphing these, I want you to plug 5 points into a table, graph those 5 points, and tell me if it is a function. So here's the table I came up with. I'm going to plug in my points of -2, -1, 0, 1, and 2. And I'm going to get the points of -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. I'm going to plug that into a graph, okay? And I'm going to see if I can use the vertical line test to see if this is a function. So my graph will look like this. Here is my graph, all right? As I write my vertical line test, okay? Again, I will see that every time I put a vertical line in here, a perfect vertical line, even though my lines seem like a little off, my perfect vertical line, I will only hit my graph line one time. Does not matter where I put my vertical line, I will only hit it in one spot. So, what that means is this is a function. It is a function. Vertical line test allows me to use that as a function. Okay? All right, so that I was given an equation. I plugged in my values that I came up with, the -2, -1, 0, 1, and 2. I got my points, graphed them, and now I figured out is it a function or not. So there's several steps in there, okay, several steps, but it all comes down to is it a function or not. Okie dokie, artichoke. All right, so now next one, it asks, there's two more here. We have this one and then the next one. So I want you to pause now, write all of this down. I know there's a lot to write down tonight, but pause, write this down, and then tell me is it a function or not. Pause. Okay, so when we look at this, each input has exactly one output. No matter if I give you this problem, every time I plug in 1 for my x, my y is 1. Every time I plug in 2 for my x, my y is 2. Every time I plug in 3 for my x, my y is 3. Okay, so when I do that, and 0, 0 of course, when I do that, I notice I have a function. It is a function. Every input has exactly one output. Function, 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 function. This is the last note of the day. Okay, so again, you don't have to write the directions. Write the equation, come up with 5 points, graph it, tell me if it's a function or not. So pause, write the table, get the points, graph, function or not. Go! Here's the table. I'm going to plug in -2, -1, 0, 1, and 2. I get the points -2, -3, -1, -2, 0, -1, 1, 0, 2, 1. After I graph it, you will notice that it's a straight diagonal line, and if I used my vertical line test, it would pass the vertical line test because if I hit vertical lines, I would only hit my graph line in one spot. So is this a function? Yes, this is a function. Function, function, function. Okay? If you have any questions, you can ask me when you see me next. I hope you enjoy your day. I will talk to you later. Bye!